A very good evening to everyone who has joined us tonight through Zoom and Facebook Live for the third installment of our ANSARA Muda Career Talk Master Series. A very special thanks to our strategic partner, Unit Perkhidmatan Bimbingan dan Counseling MRSM Taiping, Center of Foundation Studies University Technology PETRONAS, TNF Energy Sendirian Berhad, Amans Media, and Outpost Taiping for providing us with this wonderful platform to share knowledge. Before we move further, I would like to invite our Muslim friends to recite Kitab Al-Fatiha. Now today we have with us an industrial expert with 17 years of experience in his field. So the career talk for today is on electrical and electronic engineering from our special guest, Engineer Ahmed Fadzil bin Mustafa Kamal, ANSARA Taiping Batch 97, currently is the head of generations at PETRONAS Group Technical Solutions. We'd love your participation in this talk. So for any questions, if through Zoom, you can just put through the chat box, and if through Facebook, through the comment section. Without further ado, I invite Mr. Fadzil to the screen to present this talk.
Okay, Assalamualaikum and good evening, everyone. Nice to have all of you here. Right, so I just want to give a brief introduction about myself. Why don't I just move? Can I start sharing my screen? Is that okay? All right.
Yes, you can share your screen.
Okay, here we go. All right, can everyone see my screen now? I've prepared a few slides so that you can understand a bit better. Okay, so let's talk about electrical engineering.
Okay, I'm sorry, but I'm still seeing your slide. I'm not seeing Mr. Fadzil's slide.
Oh, really? Okay.
Yeah.
Okay. Share. Is that working now?
Yeah.
Great. Okay. So I'm getting a lot of messages here. All right. Okay. So let's talk about electrical engineering. Firstly, let me just introduce myself. Okay, that's me in my PETRONAS gear. As you can see, I'm wearing my coveralls. That's at one of our facilities. That is actually at the biggest facility we have right now, which I think most of you have heard of, is the Pengerang Integrated Complex. All right. So I graduated from MRSM Taiping in 1997. And from 1999 to 2003, I did my Bachelor of Engineering in Electrical at the University of New South Wales in Sydney. 2003, I joined PETRONAS as a maintenance engineer with PETRONAS Gas District Cooling. A lot of you who are at UTP may be familiar. There's a little plant at the back gate. I don't know, gate number what? That gate 4, gate, I forget. I haven't been there for so long. So there's a plant there which is known as the Gas District Cooling Plant. I used to work there for a while. And then I joined PETRONAS Carigali in 2005 after there was some restructuring in PETRONAS. And in 2015, I was appointed a technical professional generation in PETRONAS Carigali. And as of last year, I became the head of generation at PETRONAS Group Technical Solutions. I'm one of the heads of generation. There are a few of us. So that's in a nutshell my career, which is still ongoing so far. Thank you very much. So what's this all about? Electrical engineering. I don't know how many of you here are already doing electrical engineering, but let's talk about what you need to do to prepare to be an electrical engineer. The two subjects that you really need to know is maths and physics. When you talk about maths, I mean, engineering is about calculations. So you do need to know your maths. And of course, physics. When we talk about physics, if you think about engineering, electrical engineering, you start thinking of dreaming about all the equipment that you see. Right? Electrical electronics engineering, you talk about electronics, you talk about the big electrical power plants, you talk about the big electrical equipment, transformers, cables. Yep. But when it boils down to it, it really does come down to the physics of it. When it comes to deep understanding of how electrical systems work, you need to go back to the electron flow. You need to understand how the physical properties are. So your physics foundation needs to be strong. Okay. So in university, what do you expect? The first thing I got to say is that studying to be an electrical engineer is not something that's going to be easy. So I do hope all of you are prepared, especially to work really hard. There are lots of subjects that you need to know. I mean, I wouldn't say every single subject is important. There are subjects which are important. There are subjects which you realize later are actually important. So primarily it's circuit theory. That's the first thing you need to know. And then you need to talk about electromagnetism. I know electromagnetism, for those who have done it, so you know how difficult it is to understand electromagnetism, but it's something that you really need to know, because once you understand it, once you understand the deep theory behind it, you'll be able to appreciate what you need to do as part of your job as an electrical engineer. Electric power systems. Electric power systems is where the key elements of the power system analysis is. So when you learn that in university, you'll be able to apply that in your job. Yeah, a lot of people talk about saying that you only need to apply about 1%, 5%, 10% of what you learn in university. I would completely disagree with that statement. You know, as I mean, I did when I was probably in the first 2 or 3 years of my job, I realized, hey, don't use any of this. Oh, but as you grow older, as you grow wiser, as you move up, you realize that you need to understand things deeper. And then you end up going back to a lot of your university books, and you start looking back at things. Ah, okay, this is why it does this thing, and or this is why this behaves that way. So you do need to understand what you learn in university, and do not think that you're just studying for an exam, because this is going to be your job if you decide it's going to be your job. Uh, and of course, there's electric machines. Now, I'm talking here specifically about electrical power systems engineers. So those engineers are going to be involved in power system engineering, electrical engineering, electrical. Yeah. I'm not talking about those who are going to be doing control systems. I'm not talking about those going to be in telecommunications. I'm not talking about those who are going to be doing electronics, but I will get to that a little bit later. So now, let's say you've got your degree. What are you going to do next? Anyone want to ask any questions? Gary, any questions from the chat box or anywhere? Because or from Facebook? No, because I can't see the Facebook page.
For now, we don't have any questions. I think they are waiting for the end of your talk for
Oh, sure.
typing in questions.
Okay, no problem. I mean, I'm quite happy to actually have them interrupt me and ask me questions as I go along. But okay, so you got a degree now. If you manage to get your degree, I'm not worried. Most of you should be fine. You know, ANSARA graduates. I know MRSM students, especially MRSM typing students, where I'm from, most of my friends are doing excellent, and a few of us electrical engineers. And I can speak specifically for ANSARA typing. Within my own department, two of us are TPs, technical professionals, heads. I'm head generation, and another one of my juniors is the head of protection. So there are two of us there. Another one of us is in Kerte. That's also my immediate junior, and I have two more of my juniors also in my department as electrical engineers. So I dare say ANSARA Taiping has produced a lot of electrical people that are now in PETRONAS Group Technical Solutions. And ANSARA per se, our head, what we call the skill group advisor, is actually an ANSARA member as well, but he's from, because he's quite senior, so he's from Kulim. So it's a nice big MRSM family back in PETRONAS Group Technical Solutions Electrical Department. So let's get back to this now. You got your degree now. So what? Well, the industries for you to be involved in, if you have if your major is in power engineering, there's oil and gas, where I'm from. There's utilities. There's design consultancy. There's building and construction. There's transportation. And there's, of course, now what we talk about, renewable energy systems. So let me just get to one. Oil and gas, electrical engineering, oil and gas. Well, the two major areas where you're going to be looking at jobs. One is operations and maintenance, and the other is project-based. So I have had the opportunity, the fortunate opportunity really, to be involved in all areas of operations and maintenance and projects in Petronas. So I had my experience in operations. I was a maintenance operations engineer for a while, working on shifts. I was a maintenance engineer for a while, and then I moved to project, and now I'm a head. So let's talk about the operations job first. Operations jobs are day-to-day operational jobs. What you'll be doing is you will be taking care of the installation, be it a power plant or a process plant. Your job is to operate the electrical equipment. You will have subordinates. Typically, you have subordinates. You'll have electrical technicians. You will have what we call penjaga jentera in Bahasa Melayu, or we refer to them as chargemen. These people are not degree holders usually. They are technicians, but chargemen are specialized. They are specially qualified by the Energy Commission to take care of electrical equipment. Right? If you are familiar with what is the term called switchgear, switchgear is the switching equipment that is used in a substation, electrical substation. So in electrical substation, by Malaysian law, there are people who are competent and allowed to operate this equipment. So essentially, the electrical engineer, even though you take a managerial role, relatively managerial role, you're accountable to these competent people, right? So you will there's a career path which involves an electrical engineer also becoming a competent electrical engineer. I'll talk a little bit about that later. And this is one of the things that you will be doing in operations and as well as maintenance, because you don't usually find electrical engineers in operations unless, of course, it's a plant which has power generation. So if there's a power plant, you will find electrical engineers working on shifts in operations side. Maintenance job is something that you would be typically doing at any installation, be it a power plant, process plant, oil and gas platform, liquefied natural gas. You're in charge of electrical equipment, the maintenance of it, the repair, maintenance, schedule maintenance, periodic maintenance. You got to do that. And it's not an easy job. I can tell you that, because but the thing about electrical problems is that when something goes wrong, we don't usually know what exactly is wrong. No? I mean, the nature of electricity is you can't really see it. So we are a lot of times we're working blind. So that's where the theoretical knowledge that you learn in university really comes in. You need to understand what can go wrong, what works. Someone's there talking. Hello. Okay, can I mute you? Okay, there you go. I had to mute that participant. Sorry. Okay. Now, as I was saying, you would have to learn how to use the tools available to you as an electrical engineer to identify the cause of the fault. Now, in industry, you will learn various methods of fault finding and fault identification. We have something which we call RCFA, or root cause failure analysis. This is just one of them, where you would drill down to find out what's the fault. What is the root cause of the problem? So when you're doing maintenance, you know something goes wrong. Yes, something has failed. Do you just, okay, this has failed, throw it out, put in a new one? Yes, if your company is super rich and you don't mind doing that, it's fine. But sometimes you may be in an industry where you can't afford to just throw out and put in a new one. And if this failure is happening every year, it's something that you do not expect to happen every year. You need to understand what is the lifetime of the equipment, and need to understand how long it should last. So these are the things that you will be able to learn when you move to project. So in project job, you are going to learn about design engineering. So you will learn how to design. You will be responsible for the electrical design of the system. You will be responsible for purchasing of equipment. I mean, you are responsible for making sure that you buy the right equipment, and the right equipment is tested properly and delivered properly to the project site, installed at the site, commissioned. Commission means that you put the equipment into operation. It means once everything has been completed, you commission a piece of equipment. Commissioning is by definition that you take that equipment and you, just give me a minute here, I've got something. Okay, you take the equipment and put it into operations. Then you, as a project team member, what you will do is once the construction stage has been completed, you will hand that over to the operations team. That means they're the ones who are going to be operating the plant or the equipment or the installation. So it's actually quite a challenging job doing projects. Because I remember when I was in operations, I would be getting angry and yelling at the project guys. Why you guys do it that is? Why did you do that? Why do you make these kind of decisions? You know, you just give me a plant that's difficult to operate. No, it's not that. When I moved to project, I realized there are a lot of constraints. You realize there are a lot of constraints that there's monetary constraints is always there, schedule constraints, technical constraints is what can be done. So when you are in project, and especially when you've come from an operations background and maintenance background like me, you realize that, oh, okay, all right, I can't really have a Mercedes Benz. I got to settle for a Proton, right? So that's the analogy of it. Yeah, you buy something that just works, fit for purpose, the bare minimum that you need to get things done, right? So that's the kind of the job scope that you're going to be working at, be it in oil and gas. And when I talk about operations, maintenance, and project, it kind of applies to most of the other utilities as well, right? So in utility, right, this is from what I know. There's a power plant people in generation. Actually, since PETRONAS is now moving out of just pure oil and gas, this is another one of our industries where we're moving into power plants. So we're doing power generation. We have a brand new 1,200 megawatt power plant over in Pengerang. One of my best friends is the operations head over there. So it's a challenging job to operate such a huge power plant, and it's a challenging job to actually design that power plant and get it up and running. It wasn't an easy job to get the thing done, and you will be able to work in that industry as well. There's of course the distribution industry where you could work with TNB. Tenaga Nasional is the distribution, and power transmission as well. Transmission is where you're going to be operating the national grid. So if many of you have seen the huge overhead power lines and the huge pylons, we call them transmission towers of extra high voltage power lines. Well, that's part of the transmission network of the whole country. And of course, there's one which is the protection engineer. Protection engineers are highly specialized. Their specific job is to deal with the protection relays. If you have had the chance to find out what a protective relay is, protective relaying is what is what you find in switchgear. You actually find these at home, but you don't find the relays in your home. If you look at your house, you have EL. A lot of you know it as the ELCB. Some of you who've lived in maybe you've lived in bungalow houses or kampong houses, you know, when there's lightning, this thing trips, goes off. Well, that's what we call a residual current circuit breaker, or a lot of people just call it an ELCB. Well, that's just one of the smallest components of protection. So protection is a whole discipline on its own. So it's not something that you will isolate yourself from the rest of the power systems. No, you need to be able to know protection. You need to be able to understand distribution, transmission, generation. You know, and I would say also another one. But generation isn't just about generation. You need to understand electric machines. All right. So let's just move on. Okay. What are you going to do if you're a design consultant, if you join a design consultancy firm? Well, a lot of design consultancy firms in Malaysia. Some of you may have heard of Randhill. Some of you may have heard of MMC. I mean, those are some of the design consultants that I actually work with. Some of them are specialized to oil and gas. Some of them are more to the power industry. Some of them are more towards buildings. So the job there is less hands-on and more theoretical. You'll be doing engineering design. You'll be designing power systems. You'll be designing power systems for buildings, for plants, for installations, and all sorts of other areas. Okay. The job requires a good understanding of mathematics, good understanding of the engineering design principles, how to do engineering design, and you're going to be able, you are going to be required to have certain legal prerequisites in terms of registrations. So I'll talk about that shortly. Here we go. So I'm working, what now? Now what's next? Well, first thing you should do is to make sure you register with the Board of Engineers of Malaysia as a graduate engineer. So what does that mean? You will be registering with BM, and BM will assign you a subdiscipline. The subdiscipline could be one, either electrical, depending on your subjects, your major subjects. You could be electronics, if your major subjects are electronics based, or you could be, I think for Board of Engineers, either one of these two, because they just remove the instrumentation and control. So this is a recent development. Instrumentation and control is no longer a subdiscipline. So it's a new development. It is actually a discipline industry. Now, in industry, you will find that you will have to take on further qualifications, which is either through the Board of Engineers Malaysia or the Institution Engineers Malaysia to be registered as a professional engineer. That's when you get your IR. There are two levels of IR right now. One is IR without practicing certificate, and the other is an IR with a practicing certificate. As of, I think, I'm not too sure when was that. There's been some changes recently by the Board of Engineers, where for you to get the practicing certificate, you need to sit for an exam. The practicing certificate allows you to use you will have a different stamp, allows you to submit drawings to government bodies for approval. So that actually comes with some flus. So there's a fees involved with that one. There's a schedule of fees, a scale of fees from the Board of Engineers for those who are responsible for submitting documents to the government. Right. The next one I want to talk about is the Energy Commission of Suruhanjaya Tenaga's competent engineer. So as I mentioned earlier, there are people who are considered competent people. What the term means is these people have been certified and qualified and are deemed competent to take care or be in charge of an electrical installation. Now, what does that have to do with being an electrical engineer? One of the most important things you need to understand is that regardless of the industry that we work in, we are governed by laws. And the laws of Malaysia have two acts, which really affect anybody who works as an electrical engineer. The first is the Akta Bekalan Elektrik. Okay, that's one thing you should know, you need to know. And then there's the Akta Suruhanjaya Tenaga. And there's another one which is called electricity regulations. Right? So these three things are truly governing the jobs of electrical engineers. There's another one though, which covers engineers in general, which is the Registration of Engineers Act. Okay, this has to do with the registration, which I mentioned earlier, the Board of Engineers and the BEM, IEM professional engineers. So please do remember, our job, once you graduate, your job is governed by laws. So you're gonna have to know these laws. Do not underestimate the importance of knowing law. I would dare say that you don't just need to know these laws, because one of the things that I have educated myself in as part of my development of my career is that I learned all these four laws and these three laws and the regulations. I learned about the Contract Act. I've learned about the Occupational Safety and Health Act, the Factories and Machineries Act, Industrial Relations Act, Employment Act. These are all laws which are going to affect you in your working life. So if you have time, go learn about them. I mean, it's important to understand how legal terminology works, how laws work. If you think laws just apply to lawyers, you are sorely mistaken. It's extremely important as an engineer, regardless of the industry you work in, to know your laws, because the laws govern you no matter what. Right? So The last one I've put down here is, oh, sorry, I haven't finished on the competent engineer. So on the competent engineer part, the law defines that for certain voltage levels in Malaysia, you need to have a competent person. So if you realize at your home, you are either a single phase 230 volts or three phase 400 volt supply. You don't need a competent person for that. But when it comes to industry, it's different. Industrial installations may take high voltage incomers, 11 kV, for example, 11 kilovolts. So if you have an 11 kilowatt incomer, you need to have a competent person at your installation. Typically, there are various certifications available for these competent people. And these are the people whom I mentioned earlier as chargemen. So they have A0, A4, B0, and B4. The difference between the 0 and 4 certificates is that they're defined as whether the person is competent to deal with power generation and what we call synchronization, right? The 0 certificates are defined as without power generation and without synchronization competency. So the A certificates are for those who deal with low voltage installations. That means you're talking by definition of law, low voltage is anything below 1 kilovolt by definition of Malaysian law. And for B, it's up to 33 kilovolts. Right? So anything above 33 kilovolts is where we have the competent engineer. So a competent engineer is someone who has been certified, who has sat for an exam and been certified by the Energy Commission that he is competent to operate equipment at a certain level. So competent engineers are classified either as 11 kV, 33 kV, 132 kV, or 275 kV. And there's a special category which is called unlimited, which doesn't exist anymore. It is for very senior engineers. I actually happen to know one of them quite well, but he's very old actually. He's very old. He's already more than 60 years of age. But you find them very rare. But these people are special. They have been certified by the Energy Commission to be able to operate this equipment. So for 132 kV and above, you'll only find people who are competent engineers operating those equipment. If they don't operate it themselves, they are the ones supervising a charge man of either B0 or B4 who will actually physically do the operation. But the competent engineer must be there. So it is about legal requirements and legal accountability, and most importantly, it's actually about competency. That means knowledge and skill of what you need to do as a competent engineer of the community to deal with. Okay, the last one I put down here is a professional technologist. Now, professional technologist is not per se applicable to electrical engineers, but it's something that is good to have. I have actually applied for it myself, and I'm still pending approval of my assessment. So hopefully you'll be able to get that soon. It's good to have. It's part of the Malaysian Board of Technologists. You can have a look at their website and to find out what it is in detail. So I'm not going to spend too much time on that. Okay, so what's working like as an electrical engineer? First thing is the learning curve. Yeah? There will always be a learning curve no matter what job you take on. So when I started in operations, there was a learning curve. I needed to learn how to operate equipment. I started in maintenance first. Then I moved on to operations and I had to learn, oh, okay, now I'm in operations. This is going to be a little bit different here now. So I got to do things, learn differently. Then I moved on to project-based jobs. Project-based, I was in PETRONAS Gali, so I was involved primarily in offshore projects, upstream, what you find is upstream projects. So I was working in an offshore environment. I wasn't there very often, but generally it's an offshore environment. You're working in the design, construction, commissioning. So you are used to the offshore world. Then in 2016, I joined the group Technical Solutions. I was still a technical professional, but I was assigned to, as you saw in the picture, the Rapid project in Pengerang. So it's a different ball game. When you go to downstream now, I'm no longer dealing with the offshore issues. I'm dealing with the downstream issues. It's another learning curve. It's another challenge. And one of the biggest challenges that you will have to deal with in your job is not so much your equipment. It's learning how to work with people. learning how to work with your colleagues, learning how to work with the contractors, learning how to work with your superiors, learning how to work with the government and the authorities. It's not a straightforward job. Uh, it's a certain level of people skills are required. So don't think that just because you want to be electrical engineer, I don't need to learn people skills. Yeah, I don't think so. Yeah, a lot of people think, okay, I don't want to have much people skills as an electrical engineer. Why don't I become a lecturer? Well, I can talk about a few of your lecturers over at UTP because I know a few of them. I think Dr. Faunizu is a friend of mine. Even Dr. Nusha Rizal also is a friend of mine. So they are people. It's not just because you become an academician doesn't mean you don't talk to people. It's a skill. You need to know that. You need to be able to talk to people. It's something you will learn. I used to be very quiet and an introvert. I didn't talk very much, especially when I was in school. I didn't talk that much. Even in university, I didn't make many friends with the Australians who are around me. But as you grow, as you learn in your job, you need to be able to talk. So it's one thing you will have to learn how to interact with people, how to handle people. That's the biggest challenge. And of course, most importantly, you must always be ready to learn. Do not ever think you know. Um, I'm just remind you there. Don't ever think I know. You may have a first class honors degree, but don't think you know. Now, one of the most important things when you start your job, you do really know nothing, because when you enter a plant, you may have somebody reporting to you, but he's got 10 years of experience already. He knows what he's doing. Take the opportunity to learn from them. you know? But don't just think that everything that someone says is 100% true. That's one thing you got to know. It's not always 100% true. It's your choice. You need to take information and be able to filter it and understand what's going on. All right. So, okay, so here's some fun stuff. This is me. Uh, this is a large high voltage motor and variable speed drive testing at ABB Oy in Stromberg at Finland. I had some fun there. You know, that's the ABB guy who was there with me, who was there taking care of me. I was a little bit larger back then, so disregard the size of me and the size of me now. All right, so this is fun. Some of the fun stuff that I did, and this is over at Japan. 13 megawatt motor testing at Toshiba Mitsubishi Electric Industry Corporation, TMEC, in Yokohama, Japan. So as part of my job, I go around, attend testing of equipment, ensure that the equipment works accordingly. Just fun info here. This was the second trip to Finland. The first time I failed them, and this was the second trip to Japan. The first time I also failed them. So it's a job. Sometimes the vendors don't do the right thing and you fail them, and you say, look, no way, I'm going to come back, make sure it's all ready for testing after I come back. Right. This is 275 kV cable testing it at a place called Baoying, Jiangsu province in China. I don't think I ever heard of Baoying until the day I was told to go to Baoying. I had no idea where it was. It's actually about 6 hours by car from Shanghai, north of Shanghai. And the best part is that when I got there, I said, okay, do you have halal food? And the answer was, what's halal food? I was like, okay. So, it's an experience. You got to learn. So, but I had prepared a lot of brahims in my bag. So, even though I was there for about 3 days, I had some brahims with me, so I managed to eat. All right. This is switchgear testing at Changzhou, also in Jiangsu, China. Those people with me, the young lady over there is also one of Petronas electrical engineers, and the two people on my left and my right are from Samsung Heavy Industries. Right? So Samsung was our contractor, so these guys are from Samsung. All right. These are some of my colleagues from Rapid Project. This was in Manila, Makati City, Manila. We had, I do travel a little bit, not a lot. Makati City, Manila, I think we had an engineering audit for one of the Rapid contractors. So it's also part of my job at the time to do engineering audits, to check on the integrity of the engineering work done by our contractors. So coming towards the end of my talk before the Q&A, what is electrical engineering of the future? Now, here's the things that are changing right now. As far as electrical engineering is concerned, the industry, you're going to need to have coding skills. It's critical that you have coding skills, because as we are moving into the digitalization age, things are changing. Your basic skills need to be there, but you should know how to code. You should be digital savvy. You should understand how the software works. You should be able to move on towards AI and machine learning. These are things which are coming, and the idea is these technologies are not going to take over our jobs as engineers. It's not likely it's going to take over our jobs. What they will do is they're going to make our jobs easier. There's sometimes when you're reviewing, as I say, engineering audit, you have to review a lot of engineering documents. So instead of pouring through the hard copies, I could just take that soft copies, PDFs, run them through software, put some rules in place. I want you to find this, A to Z to B, you know, and the software is supposed to be able to find these problems for me and tell me where they are. And then I will look at the individual issues and decide, okay, is this an issue or not? So instead of me spending, say, 5 days pouring through documents, the software will finish that job in a matter of minutes, if not at the most maybe hours, and then come up with a list for me to review. So instead of me spending 5 days doing something, I could probably spend a single day doing it. And in industry, time is money. So that's one of the things you need to know once you're moving on to your job working world. So time is always money, and money is always what drives industry. All right. So with that, I open up for question time. I think I didn't use all the 45 minutes available, but I think I've got what they want.
So we do have some interesting questions here. So the
Okay.
first one is, can EE go into quantum computers?
Yes. The first answer I'll give you is yes, because when I was in University of New South Wales, there is a Center for Quantum Computing at UNSW. It is one of the optional subjects you can actually go into, but I believe it's university specific, because quantum computing comes under, in some places you're talking about computer engineering, right? But quantum computing involves a lot of physics. There's a lot of physics involved in it. I mean, I like to read a lot. So I do know a little bit about quantum computing, and I do know a little bit because of my time at University of New South Wales. So yes, you could go into that. Remember, first thing is about electrical engineers. It's not just about power engineering, right? Electrical engineers are involved in control engineering, telecommunications engineering, computer systems engineering, robotics, as I said, transportation industry. I mean, we are one of the most, how can I put this? People look at electrical engineering, electrical and electronics engineering as this unique engineering field. I mean, yes, our foreparents, Tesla and Edison, did start this field, but it's grown. It's become bigger and bigger and bigger. I mean, electronics is a subset of electrical, and computing is a subset of that. Electronics is going to the digital realm, and no matter what you do, you can't escape the fact that the original source of it is from the electrical engineering field. So yes, you can branch out into quantum computing, but please be aware that I would say this, even in the power engineering field, we are still highly specialized. As I mentioned, there are protection engineers. There are people who specialize in electric machines. There are people who specialize in transformers. There are people who specialize in cables. So there's a lot of specialization involved. Trying to be a jack of every single trade is, I would say, next to impossible. Not everyone can do everything. You will be good at some things, you will not be good at other things. You will have opportunities here and opportunities there. It's up to you to grab it. And quantum computing does have a definite future. There is absolutely nothing stopping you from going and becoming an expert in quantum computing.
So, Mr. Fadzil, we have another question from the same student actually. So she's asking, what recent innovations or discoveries are you anticipating with to have great potential in EE? So what's the next big thing?
Okay, let me see. What can I say without giving away trade secrets? Okay, I would say that the big thing now is energy storage. Energy storage is a big thing. We have renewable energy, we have solar, we have wind, we have. I'm directly involved in. I'm directly involved in ocean power. Ocean power generation. So the renewable part is actually the easy part. We are finding difficulty with energy storage. Batteries are expensive, are volatile, like lithium ion. I was, you saw that picture just now of me. Okay, wait, let me just go back. This picture of mine was taken with my Galaxy Note 7 before I had to return it. So yeah, so that's one of the disasters of a battery. We have that problem with things going wrong. So the energy storage business is something which is going to explode, which is going to become huge. And Petronas, as an organization, we are stepping into that. I think everyone's getting into that right now. There are various methods of energy storage, but the key one is trying to make something cheap, charges fast, holds a lot of charge. If you can break these three, you will be very rich. Again, as I said, everything that drives it is industry. It's all about the money, but that's the big thing.
So next question: what skills or topics does university does not teach, but it is required to be an EE engineer?
Oh, there's a lot of things that universities don't teach you. So I would say the first thing is how to read the engineering drawings. So I don't ever remember how to. I only learned how to read the engineering drawings when I started working. I don't know whether that applies to UTP. One of the things that's unique to UTP, I would say unique to UTP, is that is the close collaboration between UTP and Petronas. As I said, I know Dr. Nusha Rizal, I know Dr. Faunizu, I know Dr. Perumal, I know quite a few of your lecturers over there. Dr. Zaiha, I don't know Dr. Zaiha very well. Dr. Faris. Dr. Faris is a very good friend of mine. I mean, he's already retired, right? So I worked closely with many of them. So the thing is that we have adjusted the syllabus at UTP to tailor very closely to what the industry needs. Right? And I think one thing you cannot learn at university is people skills. You will not be able to learn that. You will need to learn that as you grow in industry. That's one thing you need to know. The people skill part is something which is truly critical. And the other part is problem solving. When you learn how to solve problems, what you think you learn in university is something that's not quite 100% problem solving. You think you know it, but as you work in industry, you realize there's a lot more ways to solve a problem. As they say, there's more than one way to skin a cat. Right? Okay.
So someone has actually brought in Elon Musk into this. What are your thoughts on the Tesla Tower theory?
I do not want to say anything on Tesla Tower theory because Elon Musk has interesting ideas. I mean, is he talking about Nikola Tesla's wireless transmission technology, wireless power? Is that what you're referring to? I don't know.
I'm
The Tesla
confused.
Tower, is it Nikola
There's two
Tesla's?
possibilities here.
Yeah. Is it about Elon Musk or about the wireless
Or Nik-
power, the wireless power, that huge thing that Nikola Tesla built in the US? I mean, nobody knows how that thing works. There's
okay,
no
we have a confirmation. We are talking about Nikola Tesla,
Nikola,
actually.
yes.
Wireless power.
Nobody knows how it works because those notes were destroyed,
Yes.
and they were actually confiscated by the U.S. Government, and nobody knows where those notes actually are. Because I have no doubt that Tesla discovered something. I mean, we all know that, between Edison and Tesla, I would always choose Tesla, but
Yes.
I would now choose Edison's method of power distribution. Why? Aha, that's something else. That's what something for the audience to think about. Why I say DC is better now. Think about it.
So, what is the most essential skills that an electrical engineer should have? Besides, I think you mentioned just now about communication skills and people skills, but
That's
anything
depends on
else?
your, communications and people skills are necessity. Your technical competency is essential. You should know your subject matter. You should know what you're talking about. My mentor, I have a mentor actually that's been someone who's been guiding me over the years. He once told me one thing. You know, if you keep quiet and don't open your mouth, people don't know that you don't know. When you open your mouth, yeah, that guy doesn't know anything. So sometimes it's knowing when to talk, when not to talk, knowing the right questions to ask, and knowing when to ask the right questions. Because if you don't know, ask. That's one thing I get in being I'm also a manager, so I have to talk to my engineers who report to me and say, if you don't know, just ask. There's nothing wrong in asking, and it's the same with me. If I don't know, I just ask. You may look stupid at the time because I think it's something that happens to me every single week. Because there's always something that say, what are you guys talking about? Oh, you're talking about this. Oh, okay, all right. Now I know. So that happens all the time. So don't ever think, yeah.
Sorry for interrupting you.
No, sure, go ahead. Yeah.
So next question is, what programming language that we should master to be great in this course?
Wow. I would not be able to answer that question, but let me put it this way. When I was in university, I learned Java, and I found that useless. When I joined the job, I found it pretty useless. So I've completely forgotten all my Java. However, think about 2 years ago, I started learning Python. You know, I'm more than 40 years old now, and I started learning Python when I was at 38 years of age. So don't ever think it's too late to learn something. So, but I can't say which programming language. There's a bunch of programming languages out there. It depends on what you want to use it for. Big data analytics does use R and Python. It's one of the important languages, but it depends on what you want to do. Really depends on what you want to do. C and C++ the granddaddy of programming languages. Yeah, but when I was in university, I did learn assembly. I've completely forgotten all my assembly because I didn't use it. But it depends on where you're going to go. If you're going to go into electronics engineering and you're going to do computer-based engineering, you will want to learn some languages which are suitable for your job. So, but if you want to make money out of doing apps, go ahead and learn whatever language that's suitable for you to sell an app. I would say there's an unlimited potential if you want to be an electrical engineer that does software development. There's nothing wrong with that.
So next, Shenyang wants to know more. He's asking you to share about manufacturing and structure of photolytic converters. That's
What?
very specific.
I'm sorry about what the photolithic.
Photolytic converter.
I'm sorry. I do not know what you're talking about. I'm really sorry. I do not know. Photolithic converters. Are you referring to photovoltaic technology?
Yeah, I did he correct it? Is it it does sound like a typo.
I'm not familiar with that. Let's see. Oh, photolytic converters. Oh no,
Sure,
I'm
whether
definitely
it's
not familiar with this. Nope, it's not on my alley, unfortunately, because I'm primarily power based, power engineering based.
then let's go to the next question.
Sorry about that.
This is from Annie, and she's asking, is there any way to increase energy absorbed by solar panels?
Yes, there's a lot of research ongoing with regards to photovoltaic technology. I would say back when I joined Charikali in 2005, we were talking only about 8% energy conversion. And now it's what, 15 years later, we are talking about near 30% energy conversion. So the process of upgrading photovoltaic cells to improve the energy conversion rate is an ongoing process. There's various methods of designing photovoltaic cells. I think in UTP itself, I think you should talk to specifically talk to Dr. Zaiha, if I'm not mistaken. He's one of the people whom I know who's involved in this one. I think it's also the materials engineering department where they're doing this transparent solar cell at UTP. But the thing is that it's not very efficient. So there's high efficiency, there's low efficiency. I've met people from UKM with a significantly efficient cell. However, it's prohibitively expensive to produce. So here's the thing: it's not about as a business, someone from the business industry. Whenever I look at something, it's not about how 100% efficient it is. It's about the cost and the return. Uh, it's about the return on revenue. Okay, so if I want to invest money in something, I better be able to get a good return out of it. Right. So if something is too expensive, I'm not going to develop it. So it's when you want to develop something that's highly efficient, nothing wrong with that. You want to convert as much solar energy as possible into electrical power. But if it's too expensive, your cost per kilowatt of hour of energy produced is going to be high. Right. Say, for example, now the industrial tariff in Malaysia is about 35 cents per kilowatt hour. Right, that's the industrial tariff. So if you end up with a solar cell that produces electricity at a your cost is 75 cents per kilowatt hour. How exactly are you going to sell that power? Now, nobody's going to buy it because you can't sell it at 75 cents. You need to make some profit. So the business acumen part is a necessity for working in industry. I think that answers one of the earlier questions. What other essential skills? You're going to need to have some business acumen, understand how the commercial aspects of the job is, and make sure you are able to identify business opportunities, business threats, and how you're going to make an informed decision on the technical point, which includes the business aspect. So yes, you can improve the efficiency. There are improvements in efficiency in solar cells, but it depends on the cost of it. Okay.
So next question we have from No. So she's asking, how far has EE gotten into absorbing or manipulating lightning?
I love that topic, but we are still nowhere with regards to that. I actually have a personal interest in seeing how we can do this, but the thing with lightning is that it's difficult to harness the energy from lightning. you'll be talking about typically 50 kA, 60 kA per lightning bolt. Every time lightning strikes, we have about 50 to 60 kiloamps. So then you go back to the charge calculation, the value in coulombs. So how are you going to take that energy in the split second that it happens and charge up energy storage? Because if you have something that can store that energy instantaneously, fine. But if you know your I square R calculation, P equals I square R, that P value is the heat dissipation. So whenever lightning strikes, fine, but you got resistance in whatever conductor which you're using. And that I, which is huge in value, that I is squared, talking about 60 kiloamps, 60,000 amps squared multiplied by the resistance. That's the amount of heat that's going to be generated and thrown out. You know, so to get that energy into storage, it's not easy. I mean, we are still nowhere near figuring out how to harness lightning. But if you do figure out how to harness lightning, I would like to work for you because I know you'll be very, very rich.
Next question we have is, how can we improve or modify the photovoltaic process efficiently?
I cannot answer that question. I'm unable to answer that question because you're talking about the cell itself. The cell itself is another discipline entirely. There's a lot of physical aspects to a PV cell. I'm not directly involved in PV cell design. I'm involved in application of PV cell design. I can't see. I told you. I told everyone earlier. You will be knowledgeable in one area, but not in all areas of electrical engineering.
So the next one we have is, will Electrica become a trend in the future instead of a hydrogen-powered or fossil fuel-powered cars? Electric cars.
Okay. I am a believer in electric cars. I would say that I'm a believer in it, and I believe they will replace combustion engines in the future. The biggest stumbling block, I think, was the one I talked about, one of the earlier questions about energy storage. If there's a way, which I just happened to come across this a couple of days ago, somebody claims to have made a breakthrough in terms of the charging time of a very specific aluminum oxide cell. Aluminum oxide cell, and yes, it doesn't have the same energy density as lithium ion. When you talk about energy density, it's per volume. So if you have a cubic meter of a battery, cubic meter volume of battery, how much energy can it store? So this battery stores about 60% of what a lithium ion can store. However, it can charge 10 times as fast. If I can charge it 10 times faster, and if I can charge it as fast as it takes to fill up petrol at the petrol station, I'm going to have a winner. So whoever decides to find a battery that can actually make EVs better is the winner. The biggest stumbling block for EVs is the battery. The battery is what is holding EVs back. Once the battery conundrum has been solved, and I believe it will be solved within the next 5 to 10 years, I do not see it stopping. The EVs are a juggernaut that will happen. I mean, I dare say that because I would say my company is also involved in it.
Okay.
I'm not personally involved, but a good friend of mine is doing it. So yes, it's something that will happen.
So Farkin wants to know, how can we invent something that people say that idea is crazy or impossible to a realization?
That's I don't know whether whether I'm the right person to answer this kind of question. The thing is that if you have an idea and you think it could work, don't I mean the how would I say this? A lot of people told the Wright brothers you can never fly. So start from there, right? Nobody believed anything heavier than air could actually fly at one point in time. At one point in time, people believed the sun revolved around the earth. Well, and then one point in time, people thought the earth was flat, and people start thinking the earth is flat again today, even though it's beyond mind-bogglingly ridiculous. So don't think that your crazy idea is not an idea. Don't, if you have an idea, go ahead with it. But try to learn as much as you can about the science which can actually help your idea happen. If there is a scientific theory, or there's a scientific barrier to what you need to do, then find ways around that scientific barrier. Okay, I mean that's what I would say.
So, Mr. Fadzil, for the next questions, I'm going to just compile a few of them. So, some of
Okay.
the students want to know how much will electrical engineer make. So that's the first part of the question. They want to know about the salary, and then they also want to know about job demands, especially in the current situation.
Okay. Let me put it this way. I actually do. I'm going to answer the second question first. Job demand. There is a job demand for electrical engineers. There's always a job demand for electrical engineers because it is one of the core engineering disciplines. I would say the core engineering disciplines are: one is electrical, two is a process, three is civil, and fourth is mechanical. These are the four core engineering disciplines which exist. All right. So everything else tends to be a derivation of this. So now electrical engineers, there is a demand. I'm on LinkedIn. I do actually subscribe to LinkedIn job alerts, not for the sake, I'm not looking for a job, but I just want to see what's going on in the market. So I do get weekly alerts of jobs that actually match my profile. And actually I created that profile about 5 years ago. So it's not exactly matching my profile today, but that's fine. I mean, I know what kind of prospects there are out there. Reasonably, when you talk about salary, I dare not say what to expect because I can communicate what I believe in. I believe there's wage suppression in Malaysia because I can compare and look at salaries of electrical engineers across the globe. Oil and gas industry, utility industry, consultancy industry. I mean, to me, based on our cost of living, you should have an entry salary, and you should not be less than 3,500 per month. That's what it should be for somebody who's qualified as electrical engineer. However, we are seeing electrical engineering graduates being employed in a technician role and being paid salaries of 1,800 to 2,000 a month, which I completely find offensive. I find it very offensive that employers are willing to put graduate engineers doing a lower level job. And there's also vice versa. I found technicians being put into jobs which are meant for engineers. And these are diploma holders. They're not degree holders. So technically they are not allowed to do an engineering job. Why do I say that? That's why I said you need to learn the law. If you look at the Registration of Engineers Act, go read the Registration of Engineers Act. I hope all of you become familiar with it because that spells out very clearly what is the definition of professional engineering work. And the definition there is something which puts it in a requirement that you must have a professional engineer doing that job. So a professional engineer is only someone with a degree in engineering, not a diploma holder, a degree holder in engineering from an accredited university. So these are some of the things that the board and the institution of engineers are trying to do to help uplift the engineering profession in the country. I'm not a member of the Institution of Engineers, but I am a member of the Institution of Engineering and Technology, the IET. But I'm certified by the Board of Engineers Malaysia. So it's something that is in Malaysia, it's an issue. Yes, your wages are being suppressed, and but it's an industry issue. It's not. I mean, If there's a political will by the government of the day to do something about it, then yes. But right now, it's I put the blame squarely on the employers, because they would take people who are at a lower level and put them in higher jobs and pay them less. So that's an issue. But you do not find this happening in GLCs and MNCs like Petronas, Tenaga. No, you don't find this happening. We are I would say we are good industry players, and we pay a fair salary to anyone who joins these organizations.
So I'll take two more questions, the last two,
Sure.
and both are to do with electric cars. So the first question is from Natasha, and she wants to know your thoughts on solid state batteries for electric car. So that's the first question. And I have another question from Annie, who's asking, what about transparent solar panels on the windows of electric cars? So the cost might be high when you buy it, but she's talking about the long-term use of it. Will it be financially, how do I say, will people still buy it?
Okay.
There's two questions here.
I'm gonna answer the first question first. Solid state batteries. Now, I believe Toyota Motor Compression is doing the current research in solid state batteries. Solid state batteries are something which is part of the energy storage industry as a whole, and the fact is, as long as these batteries are able to meet the three criteria I talked about earlier: cheap, fast charging, high energy density. Means these are the three criteria that is needed for electric vehicles. So if you meet those three criteria, regardless of what the battery is like, they will be able to sell, right? And of course, there's another issue. There's a fourth issue, which is of course safety. Safety is always a concern. That's why lithium-ion batteries have some issues, right? Because there is a safety issue with regards to thermal runaway, which results in the lithium-ion battery catching fire and burning itself. Thank God my Note 7 didn't do that. But that is an issue with lithium-ion batteries. So if solid-state batteries are able to solve this problem, then yes, this is going to be the way of the future. With regards to the transparent solar cells on electric vehicles, I think one of the things you need to understand about solar energy is that PV cells need to face the sun.
Mhm.
They need to face the sun. They need to be put at an angle such that they can maximize the absorption of the sun. So when you look at, there are various types of solar plants. If you look those that are further north or further south in the hemisphere, they use what they call solar tracking, because the position of the sun changes over the year. So they have solar tracking mechanisms which adjust the tilt of the panels such that they have maximum exposure to the sun. Equatorial areas don't need to worry about this, all right, because we pretty much have consistent sun.
Yes.
When you put these transparent solar panels on a vehicle, if they are sufficiently cheap, means when I say cheap, they need to be really cheap, because you're going to put them on a car. They need to be really cheap that they actually produce enough energy to give some charge to the car's battery. Right? If you looked at, maybe you have paid attention to the solar races that were conducted over the years. I know my university was one of the best at the solar race. University of New South Wales was one of the champions in the solar race in Australia. And remember, that race is done in the Australian outback, in the deserts, so that you could maximize the amount of sun received by the car and its panels. So that's one of the situations where it's blanketed in panels. And if you look at the design of these solar races, they're as flat as possible. So with a conventional car, you will not have those solar panels actually facing the sun all the time. And if you can overcome the issue of hotspots, solar PV cells have an inherent problem if a portion of the cell is shaded, right? If you shade one part of a solar PV cell, it will get damaged over time, especially if the other parts of the cell, because what happens is that the resistance changes there. So you're talking about that cell becoming a hot spot because it's actually getting hot due to the high resistance there, because it's been shaded. I would say when those of you who are familiar with Suryaki LCC, if you've seen the top of the Suryaki LCC, you see it's a whole blanket of solar panels at the top there. That was actually a very, very bad decision. You have two huge towers shadowing these cells at different times of the day. So there's been significant damage to some of them. I mean, I can actually see that from my office at the towers. So, you can see, and it's like, well, we didn't know back then. Okay, not just didn't know. The people who did that project probably didn't know that that's an issue. So now, whenever we design a solar power plant using PV cells, you need to consider this issue of shading. If you can overcome that issue, then you will not have any problem putting and making it sufficiently cheap. You can have these on your cars, no problem whatsoever. But it's probably better if you put them on the windows of buildings, because that's where they are. You know when you're going to be which side of the sun you're going to be facing, and I think it's already a thing. Check with your lecturers at UTP. They do have this transparent solar cell, and it's something that's worthwhile learning about. And if you want to do research in it, go ahead, become an academician, join the research fraternity. Or if you want to join PETRONAS under research, continue and get your doctorate. We have a PETRONAS Research Senam Berhad, PRSB, over at Bangi, where we're doing a lot of research. I actually work a lot with PETRONAS Research. Just as of today, there was another project which came, said, hey, Fadzil, can you handle this one? Where is it? PRSB. Okay lah, PRSB. No problem. I'll take care of that one. So the research part of PETRONAS is there. The research part of TNB is there. TNB has TNB research. Various research organizations are doing a lot of things in a lot of places. But don't ever think that something. I did mention limitations, but limitations are there to be overcome. Well, there's some things which are sure. Death is the only thing which I know is sure of. Everything else, it's up to us how we want to make things work. If we can if you come up with a breakthrough, I believe you will be very rich.
Mr. Fadzil, would it be possible to share your email address with the students, our audience today? Because some of them still have questions, maybe they can email you later on. Will that be okay?
Sure. Which email you want to share with them?
You can choose that. Maybe you can you can say it out, and I'll type it out in the
okay.
email.
You can email me at afadzil zil 21 at yahoo.com. Use my Yahoo's. If I give you all my other email addresses, they'll be flooding my emails.
So I've already put it in the chat. So students, if you have audience, if you have any more questions, you can definitely email Mr. Fadzil. So he's
don't email me asking for a job. That one is the official PETRONAS website. Don't do it.
So with that, we will be concluding our session today. So I would like to first and foremost thank Mr. Fadzil for sharing with us his experience, and also you gave us so much of details about job opportunities and the career prospects, what they need to learn, things that they skills that they must acquire, and so on. So thank you very much, Mr. Fadzil.
You're welcome.
Many thanks as well to our audience who have been watching and joining in our talk tonight. So if you know someone who would have enjoyed this talk but wasn't able to join us tonight, just search for our YouTube channel, ANSARA TEPEN. If you look forward to If you look forward to learning from more of our talks like this, just subscribe and hit the bell icon. And don't forget to give our video a thumbs up if you liked our session. Again, we would like to have this platform, if not for our strategic partners. So thanks to them, Unit Perkhidmatan Bimbingan and Counseling MRSM Taiping, Center of Foundation Studies, University Technology Petronas, TNF Energy Sendirian Berhad, Aman's Media, and also Outpost Taiping. So guys, remember to follow SOP and stay safe. With that, good night for tonight. So that's our session.
And enjoy your lockdown starting on 1st June.
1st of June. Yeah.
So stay safe, everyone. All right. Thank you. Bye.
Thank you, everyone.
Assalamualaikum
Thank you, Mr.
and
Fadzil.
good night. Yeah. Good night.
Thank you, Mr. Fadzil. It was a very interesting talk.
Thank you, Cik Fadzil.
Thank you. Thank you, Cikgu Aisyah, for being here.
Thank you.
I haven't been back to Taiping for a long time, unfortunately.
Yes. Please, tolong datang balik.
I'm actually from Taiping.
Oh, ya ke? Kat mana tu, Cik Fadzil?
I'm from Asam Kumbang. My hometown is Taiping, Asam Kumbang actually.
Asam Kumbang.
Asam Kumbang je. One of the few people who are lucky enough from Taiping to get into Taiping.
Yeah.
Okay, all right then. Okay,
Thank you so much.
Assalamualaikum and good night, everyone.
Waalaikumsalam.
Stop sharing. How do I leave? Okay.
Can we just
Great job also, Gauri, for tonight.
thank you.
Anda, thank you.
Thank you.
For Izni, thank you.
Thank you. Saya buat kerja sambil-sambil ni. Thank you.
Tak apa.
Thanks, everyone.
Buat kerja dapur
Kerja dapur. Right, saya end session
Yeah.
Alright, thank you semua.
Thank you. Bye. Good night.
Night.